Hi everyone, good afternoon, good morning. Hope you are all enjoying the Women in Tech presentation. I hope I'm audible. Okay, so let's begin today's discussion on three-tier web application hosting in AWS. Yes, we are talking about serverless. I hope I'm audible and clear and loud to everybody. Could you please confirm one of the organizers, please? Cool, good. Let's go ahead. And I am Sinduri. I'm a solutions architect with AWS. I'm here today to talk to you about three-tier web application hosting in AWS. And let's begin. I'm going to pause my video for now, but I'll come back on video once we start the question and answer session. Cool. So why are we here today? So what's the agenda? So what are we trying to do here today is we are trying to talk about three-tier architectures. We are talking about serverless, and we are also talking about single page applications. And all of this we are going to discuss in the context of AWS. So what brings us the agenda is definitely it's going to cover all the three aspects: three-tier architectures, serverless, and single-page applications, and hosting them on AWS. So what are three-tier architectures? Why do we require them? So some of the basic questions about three-tier architectures. So three-tier architectures, typically multi-tier architectures, were part and cornerstone of any architectural development these days. So we are all aware of multi-tier architectures from a point that they have been there in the industry from a long time. It's not a concept as it is. It's not new. So there are three components of three-tier architectures, of course. So there will be a presentation tier, the logic tier, and the data tier. So there can be based on your business use case, there can be more than three tiers as well. However, for today's the scope of discussion for today is going to be three-tiered architecture. Now, what does presentation tier mean? So presentation tier is where your users are directly interacting with your web page, your mobile app, UI, etc. Right? So they are going to interact. That is your front end. Typically, you call that as your front end of the application. And then there is the logic tier. The logic tier is where your which is called as the brain of your application, right? The logic tier will have the code required to translate all the user actions to application functionality, whether it is going to be calculation, whether it's going to be aggregation, whether it's going to request response transformation, right? All those logic is going to be stored in the logic tier. And the data tier is the storage that has either databases, object stores, or it's going to be file systems, and so on. So why we require three-tier architectures? Why can't we have a monolithic architecture? Or what is the advantage of three-tier architectures? Understanding this is going to play a key role in how you think as an architect on how to design the system, right? So why do we require? The the fundamental concept of a three-tier architecture is to keep it decoupled. So you have to think of it from a perspective that what is the gain would I get as an architect or the business application? What is the gain that it has by keeping it decoupled? You can scale the tiers. You can scale the tiers independently. I need not scale the logic tier in proportion to the presentation tier, nor I need not scale the data tier in proportion to the logic tier, right? So we are talking here about independently scaling the tiers, and they can be developed, managed, and maintained separately. So if you're adding new features to your presentation tier, your logic tier and your data tier are completely not affected by it, right? Those features can be developed, managed, and maintained, deployed in a code pipeline or a CI/CD pipeline without affecting the other two tiers. One of the major important aspect of three-tier architectures is granular access control for different teams, and also the network isolation, right? So some in AWS terminology we refer to it as fault isolation. And also the two aspects to it: one is the isolation part, and the other part is how do you give access. Does everybody on the team, on the application support team, do they require access to the database? Do they require access only to the logic tier, or do they require access only to the presentation tier? And also you can isolate the fault, in the sense that the fault is not, it will not have a ripple effect on the other two tiers. Should there be any kind of disturbances on in your presentation tier, it will not have a ripple effect on the logic tier and data tier. So I would assume that our participants have some amount of understanding of AWS. If not, that's still fine. In AWS, in cloud architectures, right? In AWS cloud architectures, it is very clearly whenever you're designing architectures, it comes out very prominently that three-tier architectures are the way to go. Especially in AWS cloud computing environment, our security groups, our network access control lists, the concept of private subnet and public subnet. In other words, private and public subnet means the private subnet will not have access to the internet, whereas public subnets will have access to the internet. Right? You have these components. These are the components which will allow you, which will help you design three-tier architectures in AWS. Okay, so you may have, depending upon your business case, you might have a queuing mechanism between the two tiers. You might have a message queue like SQS, or you might use any other queuing or messaging system in between the tiers. You can as well use cache system in between the logic tier and the data tier. If you want to use, you want to have more reads compared to writes, you can go through cache. But however, these are other components which will add additional value. However, the fundamental concept of three-tier architecture lies in three different layers: presentation tier, logic tier, and the data tier. Okay, so anything that we do as an architect while we are architecting in AWS, it is always important to ask the business or the use case as to why you're doing it. There should be a strong why you want to do it. So it's important to understand what three-tier architectures are and why you require, what is the benefit of having three-tier architectures. Okay, so let's go to the next component, which is serverless. So let us understand a little bit about serverless. So there's a standard definition about serverless: build and run applications without thinking about servers, right? So what does this mean? Okay, so where does the application code get hosted? Where is my business logic getting hosted? What about scalability? What about high availability? What about all these things, right? So forget servers on-prem or virtual machines. Do not think about servers when you're building and running applications. That is exactly what serverless serves to the industry. Okay, so then why do we require serverless? What is the benefit of serverless? Eliminate the need of thousands, hundreds, or thousands of servers, no operating systems to choose, patch, or manage, no servers to monitor, scale out, or secure, no risk to infrastructure caused by over provisioning, and no risk to application performance by under provisioning. If you just categorize these and automated high availability, if you just categorize all of this into different buckets, right? You have scalability, which is going to be taken care by the service provider. You have high availability, which is again going to be taken care by the service provider. You don't have to pay for what you do not use. Many a times we see applications deployed. I'm sure you might have come across certain use cases. Many a times we see this trend that we are either either over provisioning for an application or under provisioning, and we run into the problems of scalability, right? Though your server virtual machine architecture where you can use auto scaling in AWS gives you the benefit of scaling without thinking, automating the entire scaling process without requiring the administrator to go ahead and manually scale. Serverless offers the next level scalability in the sense that you don't even have to write that automation. You don't even have to think about automating that scalability, right? So flexibility in terms of what you deploy, flexibility in terms of scaling, and no servers to maintain, mainly, right? There's no operating systems to maintain, there's no patching required, and there's no servers to really pay for when you're not using them. So this is what serverless offers. Again, what is the takeaway from this slide is you have to know what is serverless as a concept, and then why you have to uh, look at serverless, right? The third concept is single page applications. Now, what are single page applications versus multi page applications? So, single page applications, in simple words, it is just going to have the entire code for that application loaded from one single request to the server without trying to pass the request to the server again and again. For example, if you have seen Facebook, right? So when you see Facebook, you just keep scrolling down and it keeps loading the page. That means the entire page is loaded as a single page application, right? uh, then you see multi-page applications are basically whenever you make a request, the request is going to be going to the server to load the page. So what problems does it solve? Why should you consider single page applications? It's quick to load. Why? Basically, because it's not taking that time to buffer from the server. The request is not going to the server, and then there is no request response coming from the server. So it's quick to load. It's smooth to navigate. Overall, it is going to enhance the user experience. It's very smooth to navigate, no multiple requests going on, no buffering happening. So the entire code is loading at a single page application. There are a lot of use cases on when to use single page applications versus multi-page applications. Single page applications are great if you have a booking website, or you have a completely microservice kind of architecture where you are having the services interact with each other on for a particular service, right? I mean, you're not loading the pages again and again. But when you talk about like enterprise level intranet site, you might have all of you might to coming from various corporates, or you might be as freelance consultant, right? So if you have seen enterprise level intranet website, that can't be a single page application because the code is going to be so long, and there's so many different links, there are so many different components into that application. So that requires a multi-page application. So please understand that every solution that is going to be presented as a single page application, or a dynamic multi-page application, or a static web page, there's a difference between single page application versus static web page, right? So please understand they are different, and why and when to use them for an appropriate business case. Now, coming to the three components that we addressed as discussed on the agenda, we talked about three-tier architectures. What are the components of three-tier architectures, and why should you think about three-tier architectures? The second concept is serverless. What is serverless, and why should you think about serverless? And the third is single-page applications. What are single-page applications, and why do you require single-page applications? What are the benefits? So once we have understood that, let's look at let's tie back all these three components through to a concept of three-tier architectures using AWS serverless platform for single page applications. So you have three-tier architecture, AWS serverless, and single page applications, right? So what are the three tiers that we have? We have presentation tier, we have the logic tier, and the database tier. In the presentation tier, I'm going to use for today's workshop, we are going to look at using AWS Amplify, and we are also looking at Amazon Cognito. We have other services. So presentation tier can have other services which are serverless and serve the same architecture of three-tier architecture. So you can use CloudFront with Amazon S3, which is very famous for hosting static websites, and CloudFront will help you achieve the low latency user proximity caching content distribution network, right? So CloudFront is going to help you. But for today's discussion, we are going to talk about presentation tier. Under presentation tier, we're looking at Amplify, Cognito. Under logic tier, we are using AWS Lambda and API Gateway. And for data tier, we are looking at Amazon DynamoDB. Now let's look at Amplify. Let's look at these services one by one. When you talk about presentation tier, right? When you look at AWS Amplify, Amplify is a set of tools that will, with no servers provision, right? It is, again, all of these are serverless. So Amplify is going to give you those set of tools that will help you build mobile and front-end web applications in a secure, scalable, full stack applications, right? You don't have to go ahead and think of Amplify as a platform which gives you the fastest way to develop a mobile and web application. We can see how fast it is. In the demo part, Cognito is going to give you the user identity sign up and sign in service without provisioning servers again. And this is going to be the formation for the presentation tier. Logic tier with the focus on AWS Lambda and Amazon API Gateway. Let's talk about Lambda. So what is Lambda? AWS Lambda provides you completely serverless architecture. It is a component which will help you deploy your code uh, completely serverless. So as long as your code runs within 15 minutes and your code will not require greater than 3 GB RAM, um, then your code is good to go to be deployed on AWS Lambda. Think of any kind of operations, any kind of transformations, especially in cases where you require simple transformations or event driven architectures. Lambda is a major component. AWS was the first one to introduce the event driven serverless compute component in cloud computing space with AWS Lambda. Lambda also allows you to do Lambda layers, which will help you nest one Lambda within another Lambda and trigger that. That is also possible with Lambda layers. And Lambda also allows you to get a custom platform. You can define what kind of, apart from the supported languages programs, you can also define the custom framework for Lambda. So you may be wondering, so okay, fine, we are using Lambda, we are having these great service called Lambda. So see, what where is the code getting hosted? Where do I store the code? How does it get triggered? So these are certain questions we should definitely consider when you're using Lambda. Your code is definitely, if you want to run a particular function, you store that function in S3 bucket, and you point that your Lambda code uh, will not be charged for storing that function. So Lambda is going to only charge you for the resources when the function is executed. How simple is it, right? No server required, no storage required. Your code is hosted. You're not paying for for storing the code. You're paying only for actually the resources, the compute resources, the CPU and the RAM resources that you're actually using. Coming to API Gateway, very interesting concept around API Gateway. I would say API Gateway is one of those serverless services which is like most popularly used in any kind of in any kind of applications where customers are looking for exposing their APIs, developing, building, maintaining, and exposing their APIs in a secure, authorized, and authenticated fashion, right? And all of this is serverless, right? So you don't have to design this architecture. They're already designed and ready for consumption. That's where the beauty of serverless comes. You don't have to think about high availability of your API gateway. How do I design the scalability of API gateway? How many APIs can the API gateway handle? If you have to design it by yourself, then you are thinking about scalability, functionality, then you're thinking about high availability. All this embedded is coming as a package as Amazon API Gateway. API Gateways is a great tool to great service to expose your APIs, build your APIs, maintain them, develop them, and it is closely integrated with Amazon Cognito and AWS Lambda. So you can use API Gateway. It is a very simple service to use. Then you have Amazon DynamoDB. If you're thinking about NoSQL databases, highly scalable, fully serverless NoSQL database, ready to go to create tables, then there is DynamoDB. DynamoDB is fast. It is meant for speed and performance. You have to provision. You just start with, you don't have to think about any servers or provisioning servers or creating the cluster for a NoSQL database. All of that is already available completely under the hood, and you are starting as an application developer, you are starting with creating a table directly without having to think about how much storage I require, with how much IOPS do I require, what is the read and write capacity do I require. Without having to make those decisions, you can modify that as you go, as you progress, as your application scales, and it is fully scalable. You don't have to think about how does it scale, how do I scale as my application requirement grows. DynamoDB offers a lot many great features like defining your global secondary indexes, your local secondary indexes, to ensure that the speed and performance for your application is met. Through different partitions, right? When you define the indexes, then it has the capability to allow you to define indexes in multiple ways so that your application performance is top notch. So let's move to the next slide. Before I go ahead, any questions, we will take the questions at the end of the session. We will allow 5 to 10 minutes for reserve 5 to 10 minutes only for the questions. So please put your questions in the question and answers. And there's a poll when we end the session that we will be talking about um, after the session is over. So let's move ahead with these three components. So how do you do it on AWS? How to do it on AWS? How do you achieve this three-tier architecture using AWS serverless platform for single page applications? What is the architecture that we are looking at today? So you have three components. Let's look at each component. You have a web browser. The web browser, the application is hosted using Code Commit and Amplify, and the application code is held in Code Commit, and then you have Amplify to expose the code to the web browser. For authentication, for users to authenticate, we are using Amazon Cognito. Cognito allows us to create the user pool, and we will discuss that in the coming slides. Then you have dynamic API calls over HTTPS, which will be the API call is coming. The backend here is going to be the backend here is going to be AWS Lambda and DynamoDB, whereas API Gateway is allowing you to interact with the backend using your APIs. So just to summarize, we are hosting a single page application using AWS Amplify. We are managing users using Amazon Cognito. The backend, we are building a serverless backend using AWS Lambda and DynamoDB. And then we have deployed a RESTful API using API Gateway. So let us look at how we are doing this one by one. I'm going to stop sharing my screen for a second. I'm going to bring up the browser to show you the demo. I hope my screen is visible to all of you. So what are we doing in the first stage of the architecture? So what in the first stage of the architecture, we are really using Amplify to host the application. So we are going to, the Amplify console will provide you a Git-based workflow for continuous deployment and hosting of the full stack web application. So you can commit, you can push changes through the Amplify, and it will start modifying it. You will see it in action right now. So many of you might be familiar, let me highlight this. Many of you may be familiar with already hosting a static website similar way on Amazon S3. So S3 is something that we have seen many a times. So I thought this is going to be a good example to learn about a new service if you have not heard of Amplify further. Okay. So I've already hosted this environment. So this environment is already hosted. So if you see, I have created a complete application, hosting of the application using Amplify. So the first steps, the steps to go through this, I'm just going to walk you through the steps in a simple way. So you first have to log into your AWS AWS Management Console, select the region where you want to host the site, which site you're going to host, and then you're going to go to code commit. I have the code hosted in code commit. I'm not using Git here, I'm using code commit, hence. So I've created the repository. So the first step is to create the repository in code commit. So all my code is residing here, and then I can clone the URL and clone the HTTPS for the Amplify to host that website. Then we populate the code commit and then enable the hosting using AWS Amplify. I'm just going to walk you through the steps here. Since I've used code commit, this is where my code is residing. So I've selected the code commit repository. Okay. And then I'm going to keep it simple with the features. And then I click on save and deploy. These are the steps. It will save and deploy. And once I deploy, it will say creating app. This is in progress. However, once it completes, it will complete all the 5 steps. So it will complete all these steps for the front end and back end environments to be ready. So there are 4 different steps under Amplify. You have provisioning, build, deploy, and verify. So once everything is ready, I can now load my single page application. Very good. My application is ready right now. Now, how do I create the users? Right now, the users have to start signing in and request for the unicorn ride. So how do I create the user base? So the second step in the process is to manage users. So how do we manage users? We will use Amazon Cognito to create the user pool and to manage your user accounts. Okay, manage user pools. It's all pre-created, by the way. I'm just going to show you the steps so that you are aware how we are doing this. I'm going to just say demo, review defaults, and then I'm going to create a pool. So you have created a pool. The task now is to ensure that whoever registers on the single page on this website, whoever creates account on this website, right? And their user details come to Cognito. That's where we need to link the application. So you'll add an app to your user pool. Go to app clients under Cognito, add an app client. Okay. I don't want to generate client secret. Then I'm going to create client app, and this is the client app ID. Okay. Here comes the next part where you have to push the changes for Cognito. So what we have done right now, we have created the user pool, we have created the Cognito user pool and the single page application hosted on Amplify. Now what we are supposed to do is to push the changes in the push these changes in the code that they have to whoever registers with this particular client app ID, you have to connect these two services. That we are going to do it by making the changes in the um, code. Go to the repository. You have to go to the config file where there is configuration. Okay. Now what is this saying is that I have to update the user pool ID. Why we are updating it, I've already explained. Anybody who registers, who creates, the user pool has to reflect that information for each user registration, and the user pool client ID and which region it is going to be uh, reflected. Why I'm not updating the API? Because we have still not integrated it with API gateway. Okay, this is where I update. Where do I get these details? You get the user pool ID from the uh, Cognito console where you have created the user pool. Okay, so now what happens is I will go ahead and register. That's a dummy account I'm using. Okay, give me one moment. By the way, I do not use that email address. So it's just created for this demo. However, I'll receive a verification code, and there's one important step that we need to see. Hence, I'm going to just log in and get the verification code. I'm doing it on the other screen, by the way. Okay, seems like the dummy account did not work. Let me redo this with another email address. Okay, the user already exists. I have already used this email address. So let me just go ahead and show it to you here by signing in. I want to show you the sign-in verification. And all of this is a single page application. That's what exactly. So this is what we want to see as a part of the authentication. Why we are getting this successfully authenticated, right? This is going to tell you that the Cognito user pool authorizer, right? This is functional right now. So you're getting authenticated from the Cognito user pool, and this is the authentication code, that the auth token that you're receiving. Okay, so this is what happened when you updated. This is the output that we get once we have updated the user pool ID in the code. So what we have achieved so far is we have created the presentation tier. Please understand, let's put it back to that particular mode where we were talking about. We did the presentation tier, we used Amplify and Cognito, right? So what we'll do next is use build the backend. So what do we do in the backend is to use the build the serverless backend. Okay, for building the serverless backend, we are using AWS Lambda and DynamoDB. So I'm going to first create the DynamoDB table. So the table is already here, but just for the benefit of participants, I'm going to create it again. Okay, I'm going to use all the default settings. So like I said, it is all serverless. This entire hosting is serverless. So the table is being created. So once the table is created, what do I want to do in the architecture is every time somebody books a ride on this, right? Every time somebody books a ride, I want the details to be recorded, the geo details to be recorded, the location details to be recorded, and a ride ID to be generated. So it's just like booking a cab. You're booking a unicorn ride. It's just like booking a cab. So in the backend, you want those ride details to be recorded and also a ride ID to be generated. So that is what DynamoDB is doing here. And what is Lambda doing? Lambda is going to do is every time the customer is going to click update, I want to book the ride, that function, the Lambda function, is going to be triggered and going to update these details in DynamoDB, and it's going to return the customer with the email notification, or because you have registered using email, it is going to return a particular ride ID, which will be the reference ID. So I've created the DynamoDB, then I'm using Lambda. So you got to create a function. So please understand, there's one major step here is that you should allow Lambda. Whenever using Lambda, Lambda should be given the permissions to be able to write data and execute that function using other services. It has to write the data to DynamoDB table. So what do you use? We use IAM role to give that permission to Lambda. So let me just quickly show you this. So I'm creating a Node.js application, and then since the role, I have already created the role for this demo, so it exists. Otherwise, you will have to create the role, okay, and create the function. Once we create the function, okay, you're going to update the code here. Okay, now what is that code? Is the code is your so what is this, what are we trying to do here? The code what we are going to write is going to change based on your use case, but what is important to understand that this is the brain of your application. What do you want Lambda to execute? What actions do you want Lambda to take? Based on what are the variables that you wanted to look at, right? So the code is I would say immaterial, what the code does, but essentially it is going to invoke the Lambda whenever there is a person, say whenever you book for a unicorn ride. So what it will return, the lambda function that we are going to write here, it is going to do two particular actions. Those two particular actions is going to be, first it will persist the details in the DynamoDB table. Second, it will return value with unicorn details, the right details. Okay, now that we have built the logic, the serverless logic tier, now the backend is ready. Now we have to integrate the front end and the backend using API gateway. Again, I have not provisioned any virtual machine throughout this demo. There's no provisioning of a server. You have not provisioned any kind of VM, virtual machine, or EC2 instance in AWS in order to go ahead and do this. So I'm going to build a RESTful API. Okay, so I'm going to create a new API. Okay, I'll keep it edge optimized. Okay, I have to use an authorizer. I have to tie the Cognito authorizer. The API has to come through Cognito. That means it has to verify that it is the same user who is trying to book the ride, who is and is also registered. This is an authorized user. So I have to tie it back to the Cognito by using the authorizers. You use Cognito here. So important point to note in the interest of time is you use Cognito here and you select the user pool. I have created a demo user pool right now, but we already had a wild rides user pool. You can use that. And I want to say authorization. This is for authorization. Okay, and you created the authorizer. Okay. Now, how do you test it? Right now, is the API getting authorized? You test it using the screen where we got the token, right? There's an auth token. You go here and test whether it is authorizing. You copy paste the auth token received here. When we clicked on write.html, we got the authorization token when we logged in. Use that auth token and test. You can test whether it is authorizing. API gateway is authorizing. The last but not the least step is to ensure that this API, now you're going to deploy the API. First create the API and then you're going to deploy the API. Go to resources. You're going to create a resource first and then create a method. The resource is going to be ride. And then I want to enable course. Once you create the resource, select the resource and then create a method. I want to create a post method. Okay, it's going to be a lambda function and define your lambda function here. Okay, so this is what is going to happen every time the request is going to come from the booking ride. The API gateway will invoke the lambda to go ahead and write in the DynamoDB table and return the request using API gateway itself. Once your API is ready, you're going to deploy the API. You have a deploy API option once your API is ready. Okay. So this is the demo using completely serverless architectures on creating a single page serverless architecture on AWS. So we have done all the 4 steps, and as you can see, it was completely serverless, no provisioning of any EC2s. So we saw the demo. The key takeaways, we should take away definitely what are 3-tier architectures, why 3-tier architectures. Hope you have answers to these questions after this session. What is serverless and why we require serverless? what is single page application and why single page application, and think about AWS serverless platform. So I'll open it up for any questions. Okay, I'm looking at some questions here. If the requirement doesn't go to server, how is the response generated? Is there some logic on the client itself? Okay, so the requirement, so all the for a single page application, all the code is going to be uploaded onto the single the code, the logic is along in the single code, so it is going to be loaded for the first time. You do not write it in a multi-page application. You're going to write the logics like, okay, now go back to the server, calculate this and get it back. So single page applications are very are simpler and doesn't require the brains on the front end. So that is how you're going to design the application. How are partitions handled in DynamoDB? Once it's scaled up, the partitions are also increased. Scaled down, what happens to the allocated partitions? This has been a question multiple times by multiple customers. So when you enable DynamoDB on demand or auto scaling, right, the partitions is something you have as a customer will not have control over, and the partitions you will control the partitions only through the partition key, which is while designing the particular table, right? It's going to that is why it is important. That is why it is very important to choose your partition keys appropriately and ensure that you're not using hotkeys, right? You know that a particular partition is going to be overwhelmed with the kind of request. You distribute your partition keys accordingly. Use local secondary indexes and global secondary indexes in order to give multi-dimensional approach to your application without doing a hotkey.